Right, so hi everybody, I'm Katie and I am co-founder and technical director at EcoSpatial Solutions, and it's actually a very special day because this is my first presentation at EcoSpatial Solutions. We've been trading for about 10 months, so we are very new. But we are a GIS consultancy, and we basically specialise in general GIS support with technology capability across all sectors. But we also support specifically around biodiversity net gain data management as well. So personally, my background is in large infrastructure. So I used to work for Costain. They sponsored my PhD, which started 10 years ago, which is pretty scary. And basically my work was developing basically enterprise solutions to support our projects with the incoming biodiversity net gain operation. So I've been involved in quite a few projects, specifically national highways, in terms of actually implementing these kind of procedures. So, and kind of what I've learned in that time is that the geospatial community wasn't really engaged with the development of biodiversity net gain, which is a massive shame because all parts of this planning actually require GIS data. So that's why I'm here today to talk to you about the kind of importance of the tech and data within biodiversity net gain. So I'm just going to give you an introduction to the biodiversity net gain legislation for those of you that aren't really aware of kind of what's going on in this field, basically what it is, what the targets are and how it's measured. And I'm going to talk about some of those data challenges we have, some of our solutions, those benefits, and then our future work that we're looking at as well. So biodiversity net gain was part of the Environment Act in 2022, 2023, basically came into effect in February of this year by DEFRA and Natural England, and requiring all non-major projects to basically have a biodiversity net gain objective within their plans. And so the minimum net gain objective that needs to be part of your plan is 10%. So this isn't 10% adding on to what you've lost. This is actually 10% once you go past your biodiversity baseline value. So what you have by the end of your project is 110% in biodiversity on your site. So hence gain. So it's not as simple as this. This doesn't really apply to irreplaceable habitats. So things like ancient woodlands, lowland fens, blanket bogs, things like that, because they're so high in value, it is literally impossible to actually get any of that gain back. So even though you have to have a very strong justification to remove these habitats anyway, you'll be coming up with a bespoke compensation package for these irreplaceable habitats in addition to your 10% net gain goal as well for the rest of your site. However, if you want to just enhance these irreplaceable habitats, they do count towards your net gain objective. So we're going to talk about measurement. So biodiversity is quite a complex concept and can be measured in so many different ways, which are really dependent on context and scale. So biodiversity net gain itself doesn't look at things like species, nesting, migration, kind of at the local level. Instead, it uses a proxy called habitat hectares, which is, means that it's dependent on its habitat type, its area, and the condition. So let's say you have a woodland and you have bats in your woodland. Even though it would be fantastic for biodiversity for you to add bat boxes, that won't necessarily add to your biodiversity unit score. So it's very important to not get fixated solely on biodiversity net gain when it comes to your sites, even though it is basically what is required. So for calculating biodiversity net gain, we have to calculate our baseline. We then have to calculate the loss, and then we have to calculate the gain. And we have different metrics to do this. And our tool at the bottom is from DEFRA. It is the biodiversity metric tool. I think there's either a new version coming out or it's just coming out and then it's going to be set for a while. So it's an Excel spreadsheet that basically allows for the quantitative reporting of biodiversity net gain in 3 different unit types. So we've got habitats, hedgerows, and watercourses. So those values are independent of each other, and if you have any of them on your site, you're expected to report them independently. So a 10% plus gain in habitats will have 0 effect on your percent gain of hedgerows, which will have a independent from your watercourses as well. So our first metric is distinctiveness. So this is something that is predetermined based on your habitat type. So a classification system is UK habitats. And like I said, this is predetermined. It ranges from very low to very high and is given a numerical score. The condition, which is our next metric, is basically given based on habitat conditions. So we have to send an ecologist out into the field to fill in an assessment, and then we get our condition score from that. Condition can be approximated, but if you were to submit officially for Biodiversity Net Gain, you would have to put ecologists out on site. And then we have strategic significance. So this is whether your site is part of kind of a local development plan or is seen as kind of significant within Natural England's kind of habitat network. So all of these numerical scores are multiplied together with the area of the habitat in hectares or the length of the habitat in kilometres to give us our baseline. The loss is calculated in exactly the same way. With these metrics, we would use a vegetation clearance design to be able to quantify that data. And then when we calculate the gain, it comes a little bit more complicated. So we have our distinctiveness and condition of the habitats that we want to establish and we want to restore. However, depending on what those habitats are, there are decimal multipliers that actually reduce that number, so it kind of makes it a little bit harder to reach that, that gain target. So we've got the difficulty creation of habitat, the time to target condition, and the proximity to site. So for example, if we are planting a woodland, that time to target condition is going to take a lot longer than, say, a grassland. And so that decimal multiplier is lower, so it brings that value down as well. It's basically a deterrent for removing habitats that take a longer to establish. And then proximity to site, it's going to be very, very common for a lot of sites to have to offset away from their site, but there is also a penalty for this as well. And it just means that 1 hectare of woodland that's removed on your site is not equivalent to 1 hectare planted off-site. So there are a lot of aspects of Biodiversity Net Gain which are very ecological, around condition assessments, habitat assessments, things like that. But something that's really overlooked with the calculations is actually all the challenges around data. And that's kind of where kind of our expertise at EcoSpatial really come in. Because we have had this kind of experience of implementing these, I've seen personally where those challenges lie and where the time really starts to add up, and also where those inaccuracies come. So first of all, we've got issues with our red line boundary, and all of these may seem very simple and common sense, but these are all issues that I've encountered, and this is to do with inconsistency. So your baseline red line value in the design being different from your vegetation clearance red line boundary being different from your landscape design, which when you then have areas that maybe haven't previously been surveyed as part of the baseline, you can't include as part of the vegetation clearance or the landscape design, otherwise you're going to have to go back and resurvey again. Boundaries may just be genuinely badly drawn and inaccurate, or they may not fit within the land registry boundaries, and this is within the Section 106 agreements where that is really important. Then there are also issues with habitat boundaries, so this is normally input from ecologists. Their boundaries just may be incorrect with a habitat that is going over into a different habitat but classified incorrectly. We then have potential overlap of polygons themselves. So you have potential areas that are counted twice, and then you can also have gaps as well within your site, which means there are some areas of habitat that aren't being calculated at all. And then one of the really interesting ones that I've come across as well is actually accounting for slope. So this isn't something that's done at the moment, and you can imagine slope has a lot of kind of ecological kind of consequences in terms of classifications and condition. However, if you're thinking about it geometrically, a 2D versus 3D approach, we're all looking at polygons from a 2D standpoint. And if you've got a very steep slope, then your measurement is going to be underestimated because your measurement on the ground within that slope is going to be different from above. So we also have some just general errors, just user errors. Just from maybe inputting numbers wrong into the system. Maybe that's just the wrong number, a multiplier of 10. We also have ecological user error as well, and I'll get to the ecologists, but so much of BNG is dependent on the ecologist. And I'm just going to put this as a waiver out there. I don't hate ecologists. I really don't. But there is so many processes within this that are so subjective and so dependent on that one person that is where quite a lot of mistakes can come in. And then, just to get on the ecologists a bit more, the interpretation of their maps. And I will die on this hill. You think a doctor's handwriting is bad? You should try reading a map an ecologist has scribbled on in the rain and has then folded. It is absolutely impossible, and also apologies if there are any ecologists in here. And I have spent a lot of time with the ecologists themselves and them trying to interpret their own annotations, making sure that I am labelling habitats correctly or things that may have changed on site. And then we also have data overwhelm as well. So a lot of places are starting to incorporate biodiversity net gain and getting all this data, but not actually understanding what to do with it. And so that's an area that we really do specialise in actually exploring your data, being able to interrogate that data, and being able to use it as an evidence base for decision making. Which takes us to the kind of work that we do at EcoSpatial. So we have a data optimization kind of service for biodiversity net gain. So we are able to process pre-existing site data so that it can line up with the GIS standard given by DEFRA. We can then actually perform those calculations within GIS, within the attribute table, so you can understand what your baseline is within our software. And then we are also I've basically put together those kind of data standards and requirements to make sure that the scores are as accurate as possible. And then we can look at some analytics, and this is where it gets really interesting. We can identify areas of high risk by understanding our baseline as early as possible, potentially areas that we can avoid in the vegetation clearance, which means we don't have as much to gain when we're doing the landscape design. And we can also look at potential enhancements opportunities as well. So, for example, if we wanted to see, do we have irreplaceable habitats that we could potentially add to, or areas that are of potential low condition that we can enhance that are some easy units to gain. And then, as I said, we are a GIS consultancy, so our visualization is obviously very GIS-based, but we can create a user-friendly interface and kind of dashboard functionality that is really good for the user to actually start to understand that data themselves. We don't want to kind of gatekeep the uses of this data, and so I'm really looking forward to kind of showing you that dashboard functionality. And then for data collection, we've created a bespoke survey system, which really makes the job of the ecologist a lot easier with auto populations, allowing them to spend less time on site and kind of reducing the potential for error. So as I said, we've only been operating for 10 months, but we've been working with the Canal and River Trust in that time. They have really great ambitions around nature recovery, and they've wanted all of their biodiversity net gain operations to be within their Esri GIS platform. And so I was brought in basically to create that platform for them. So as part of their phase 1, they had their entire network surveyed. So we've got calculations and predictions for all of the habitat types and all of the conditions for every single habitat polygon within the network. And then I was able to process that into a way that we could add it to their Esri enterprise. And then I created a dashboard functionality which allows them to then explore and interrogate the data. And then we are getting ready to test the survey system for their ecologists to go out and update. So I can't show you their exact dashboards due to sensitive information, but EcoSpatial are now an Esri partner as of 3 weeks ago, which is pretty exciting. So that's meant I've actually been able to create my own demonstration material without worries of getting into trouble with clients. So this habitat dashboard, so this is showing our baseline. And, oh, I've just lost the mic. Sorry about that. So what we can do with the dashboards is that we can show different information at varying different scales. So we can look at the entire habitat network. I thought that was my buzzer of time up. So yeah, we can look at the entire network. So this example is just habitat types within Snowdonia. We can also look at the different, the breakdown of habitat types as well, and totals within there. And then we can also look at individual polygons too. So we've got our big map in the middle, our legend over to the right. And then below we can add photographs for any photographs that are collected out in the field. And then if you can, I won't be able to make it out, but we've got a light blue the outline here, which is a selection of habitats within the data. And then on the left, we've got the chart showing the breakdown of habitat types from that data. And then below, we've got the individual attribute data of the individual polygon. And then we can also add buttons and links to things like SharePoints, websites, so that our person can also easily access the DEFRA biodiversity metric as well. And then at the bottom, we've got some little widgets. So we have our analysis tools. So this means that the user can kind of perform some geoprocessing tools. So looking at things like summarizing within an area, they can create buffers, look for hotspots, and then they can also export that data in a GIS format. Then you can also add data as well. So this could be locally sourced data, kind of your own data, site data, surrounding data, or it can also be all the open source data as well. Then we can look at filtering and exporting data, and this is where the Trust has really utilized this tool. So we can filter, so let's say we want to find 3 units of canal within the Oxfordshire Local Planning Authority. We can put those filters in, it will zoom to it on the map, and then we have the option to export all of that data with the export tool as well within a CSV format, which you can then copy and paste straight into your metric tool as well. So these kind of dashboards are completely bespoke based on needs. I kind of threw as much as I could in this to just show you that functionality. But it is really impressive what basically a non-GIS or a non-environmental expert can do just going onto this dashboard and just interrogating the data. And I always try and make it very clear to anyone using these dashboards, you can't break it. Like, you literally can't break it. So just have at it, have fun, and get what you need from it. So the next is our survey system. So I will play this. It's a couple minutes. 2 minutes left, okay. So I'll quickly play this, and then if anyone wants to talk to me about the benefits and our future work, then we can do that afterwards in the break. So basically what this tool allows us to do is have the ecologist go out, and all information that is predetermined or dependent on geographical reference is automatically populated within, just within the survey. So this means that all the ecologist has to do is input that habitat type, and then the specific condition survey will pop up underneath, and all they do is fill that in and submit. An email is then sent to the GIS team at the Trust to say this has been updated. They will get all of this information and they will know exactly where it has been updated. They can then do a validation test to make sure any new features are drawn correctly, thus reducing a lot of those issues. I will just slide on from this. I think these slides will be available, but if anyone wants this video, then please feel free. How do I go forward? Oh, there we go. So just some quick benefits on this kind of GIS support around data management is it helps accuracy and compliance with the legislation first and foremost. It's really important that you're not getting things back from the councils when you're putting in your proposals. And we're reducing that risk of inefficiencies, having to redo work and incorrect calculations. We're reducing costs by making on-site updates more effective, so the ecologist is going to be able to spend less time on site, which also adds to that safety aspect as well. It allows all the BNG data to be updated and relevant. Habitat surveys go out of date within 18 months, so it's really important to have a system where you know when that data has been updated and you have the capability to go and update it pretty easily. We also means we can standardize by having kind of the GIS platform as a single source of truth to consolidate all of the Biodiversity Net Gain data. And then there's also opportunities to integrate with other departments as well, so estates management and natural capital. So these are some of the benefits that we've really realized from Canal and River Trust. We've got some other things in the pipeline that we're building. We really want to kind of create a service for data accuracy that allows you to input your data and then we can flag the errors and get those corrected, constraints reporting, things like that. And then we're also planning on writing a white paper around GIS standards with the hope of kind of legitimizing those standards within Natural England to make sure they're all adhered to. In summary, everything. Biodiversity net gain legislation, we need an objective of 10%. There are many challenges caused by data inaccuracy. GIS spatial tools are ones that can support developers with those accuracies. And this is just such a relevant place to be at the moment. And I think that's it. Whew. No, thank you.